In this video, we're going to look at evaluating another limit that within it holds a special trig limit, namely this one that we have highlighted here. When we're first given a limit problem, the first thing that we always do is we ask ourselves, can we pass to the limit? Can we plug in the value that our variable in our function's approaching to find our limit? And if so, we're done. We don't have to worry about doing anything else with the problem. We can move on. But if not, then we have to worry about doing some other kinds of manipulation. So first, let's see what happens when we plug in 0 for x. Well, here we get 11 times 0, which is 0, plus 11 times 0 times cosine of 0. So that gives us 0 times cosine of 0, or 0 times 1, which is 0. 0 plus 0 on the top is 0. Sine of 3 times 0 is sine of 0 over 0. So we arrive at 0 over 0, which is one of our indeterminate forms when we're looking at limits. When we reach one of these forms, we ask ourselves, can we factor? Can we multiply by the conjugate? Or in cases of trig like this, can we break it down to more readily use something like this, a well-known limit result for trig? And the answer for this question is we can do a little bit of factoring in the numerator, and we can also work to break down the trig components of this function to make it more easily visible as to what we're dealing with. So the first thing I'm going to do is I'm going to factor out an 11x from the numerator here in our function. We're not messing with manipulating the limit in any form or fashion. We're just using some algebra to factor our function a little bit. So we get left with this in the numerator. And what I'm also going to do is I am going to split the fraction from our original function into two fractions like this. So we're dealing with a product of sorts. So this is what we have going on here. We have this that we factored and split into its own fraction, and we have this that was the denominator of our original fraction in our function, and now we have it being multiplied times the original numerator. Now, we see that this closely resembles this special trig limit that we're dealing with. And we know from the previous two videos for this section that we can use the rule that the reciprocal of the limit is the limit of the reciprocal, and vice versa. It works both ways. It kind of gets twisted in your head a little bit, but you can say it either way, it means the same thing. The limit of the reciprocal of this is the reciprocal of its limit. So as long as we have the same thing in the argument of our trig function as we do in the opposite half of our fraction, the limit will still evaluate to 1 no matter which part of the fraction that sign is. We just have to make sure that this and this match. And we don't have that right off the bat. But what we can do is we can multiply the numerator of this product here by a factor of 3x. Or actually, let me rewrite that. 3 times x. So we're multiplying the numerators by a factor of 3 and a factor of x. But once we do that in the numerator, we also have to do it in the denominator, because what we're ending up doing here is we're multiplying this original function here, which we broke down to be a product, by a specialized version of 1, because all this is 3x over 3x, or just 1. So all we're doing to this product is we're multiplying it by 1. It's just a very specific one that helps us utilize some well-known results. So what we're going to do here is we're also going to use the notion that multiplication of real numbers is commutative. So what that means is when we're dealing with all multiplications like we are here, what we can do is we can take bits and pieces and put it where we need them to be represented. So what I'm going to do is I'm going to put this 3 times x here in this numerator of the first fraction, and I'm going to take this x and put it in the denominator of this first fraction here. So what that ends up giving us is I'm going to rewrite what we have here. Limit as x approaches 0 of 11x times 1 plus cosine of x over x times 3x over sine of 3x. So now you may be asking yourself, why in the world did you put that x on the bottom in here? Because what we can do is we see that this is 11 times x times this expression. So since we have multiplication here and we're not canceling any one part of this sum here, what we're going to end up doing is we can cancel factor by factor these x's here, because they're just pieces of multiplication. When we come to multiplication in fractions, anything that's in the denominator of one fraction can be canceled to any factor of the numerator of a fraction. So what we have is we can cancel this x and this because they're parts of multiplication, or they're factors. So After doing that, this multiplication simplifies a little bit and makes it a little bit easier for us to evaluate. So we get this, as we were left with up there, times that, over 1 times 3x over sine of 3x times 1/3. So now once we arrive here, we see that we're taking the limit of a product. And we can also use the product law for limits, or the limit of a product is the product of the limits, so long as the limits by themselves, so namely the limit as x approaches 0 of 11 times 1 plus cosine of x, and the limit as x approaches 0 of 3x over sine of 3x, as long as those both individually exist, we can take their limits individually and then multiply those limits together to obtain the limit of our original function. We know that the limit of this second factor here, this 3x over sine of 3x, exists because, again, the limit of the reciprocal is the reciprocal of the limit. The argument of sine matches with what's on the opposite half of the fraction, so we can use that. This evaluates to be 1, and we see that this first factor here, we don't necessarily have a special trig limit that we can use, so let's try passing to the limit here. Can we pass to the limit of this as x approaches 0? If we plug in 0 for x, we get 1 plus cosine of 0, or 1 plus 1, which is 2, times 11, which is 22. So this first factor here also evaluates to a limit exists. This one does as well, and this is a constant multiple, so we don't have to worry about evaluating it. We can break this multiplication into the product of its limits. What that's going to look like, something like this, over 1 times the limit as x approaches 0 of 3x over sine of 3x times 1/3. We said that this evaluates to be 1 by using the special trig limit that we have. We bring down the constant multiple of 1/3, and we also said that this evaluates to be 22. 11 times 1 plus cosine of 0, 1 plus 1 is 2, 11 times 2 is 22. So now we get the limit here, this limit, and this limit. We multiply them together to obtain the limit of our original function, which works out to be 22 over 3.